Okay, so in this video, we're going to talk about two more problems, which is 24 and 23. As for the very last problem, we're gonna dedicate one single video to it. So it will be video number 3. And in this video, we're gonna start with the problem number 23. It says that we've got 5 different integers, each greater than 0, so 5 positive integers, and they are different, and they sum up to 264. And the greatest common divisor, okay, number theory is kind of fun. It's the greatest common divisor of these 5 possible integers is d. And what is the sum of the digits of the largest possible value of d? So basically, we need to find the largest possible value of d, and the sum of digits is just a trivial thing. It's just one way of asking the question. Anyways, we're gonna find out d. So d is the greatest common divisor of the 5 possible integers, and of course we want to find the greatest possible value of d. So let's just translate the first 2 sentences into some math expression, and let's see what we can do. Okay, but I think I need some more space on paper. So okay, here we go. 5 different numbers, because the greatest common divisor, the GCD, is a d. That is to say, the 5 numbers are d. Let's say d, the xy, x1 maybe, dx2, dx3, dx4, and dx5. Okay, that's the 5 numbers. Because they are all different, so it's strictly larger. Okay, and because d is already the common divisor, that is to say x1, x2, x3, x4, and x5, their GCD would be 1. They are co-prime. And the co-prime is not a good word here because I'm considering 5 of them in one go. But anyways, the GCD of them is 1. Okay, if you want to write GCD, okay, because I don't have the habit of writing that, I just write a pair of brackets. But anyways, the GCD of these 5 numbers is 1. Okay, and the d would be the GCD of the 5 original numbers. And there's one more thing to consider, that is the sum, which is 264. That is to say, d times the sum of the 5 x's would be 264. Of course, what we need to do is factor this. 24 times 11, right? 24 times 11, that is 2 to the power of 3 times 3 times 11. Okay, that's it. And let's see what we can do, because we want to make d as large as possible. So let's say, of course, we're gonna say that d, how about let d be a 264 itself? Okay, in that case, d is very large, but that is not possible, because you see, we've got 5 numbers here, and these 5 numbers cannot add up to 1, right? If d was 264, then these 5 numbers would add up to 1, and this is not real. So d has to go down a little bit. But now we get an idea. The smaller this part is, the larger the d is. So we want to keep this part as small as possible, okay? And what does that mean? All these 5 numbers are different, okay? So let's just check this part. x1 plus x2, x plus x3 plus x4 plus x5. There are 5 different numbers, and they are all positive integers. And if we want this value to be as small as possible, we would like to do something like this. This is no smaller than 1 plus 2 plus 3 plus 4 plus 5. That's the very first 5 integers, 5 positive integers. So this is already 15. That is to say, this part is no lower than 15, okay? So this part is no lower than 15. We're gonna find from this something that is just over 15, maybe 15, but we don't have a 5 here, so 15 is not attainable. We're gonna find something that's just over 15, and that would be maybe... And still, we need to double check because we've got this, okay? But anyways, let's just see if we can get something just over 15. In that case, d would achieve the largest possible value, the greatest possible value. So let's see if we can get anything that's just over 15. I see that, do we have something good? 16 is not okay because we've got only 3 2's. And not to mention and 19 and 17. How about 18? 18 is not enough, but because there's only one 3, so not 18. And then I think we should go all the way to 22, right? Because we've got 2 times 11. Here is a 22. So maybe this is a 22. And in that case, if this is a 22, the rest would be 3 times a 2. That is, yes, 3 times 4. That is 3 times 4. That is 12. Okay, so in that case, D would be 12. If this is 22, then D would be 12. If this has to be over 22, then D will go further down. D will need to go further down. Okay, and so let's double check and see if we can make the 5 numbers add up to 22. That is to say, let's say, let the first number be 1, the second number be 2, the third number be 3. I mean, this is x3, okay? And the x4, I'll just write it, okay, to make it clear. x2 be 2, x3 be 3, x4 is 4, and x5 would be 22 minus, this is 10. 22 minus 10, that is 12. And in that case, of course, the GCD of these 5 numbers are 1. They are kind of co-prime, so we don't have to worry about this. This is actually, we've got 1 here, and that decides everything. And so far, they add up to 22, and the GCD of them is 1, okay? And in that case, D would be 12, and this is, as we said, the largest possible value of D. So I think that's it. If you want to ask what these 5 numbers are, then it is like 12 times 1, that is 12. The second number, 12 times 2, 24. The third number, 36, it is 12 times 4, that is 48. The last one is 12 times 12, that is 144. But this is trivial. It's just 12 times 1, 2, 3, 4, and 12. Okay, so this is how we constructed the solution. And by the way, we are looking for the sum of digits of that very value of D, and the value we're talking about is 12. So answer should be 1 plus 2, which is 3. Boy, okay, we've got option here, and I think that is the correct answer. Yes, and the D actually is a 12. Okay, this is the number we've been looking for. To make this as large as possible, we have to make this part as low as possible, but this can't go too low, as I said, because it's already 15 if you just take the first 5 positive integers. So it has to be over 15, and this has to divide this, okay? It has to be divisible, so it has to be some factor. That is why we're gonna start with 22. We can't start with a 16 or something like that, okay? We don't have a 16 within. Okay, so that's the idea. Now let's move on to problem 24. Okay, probability. A network of pathways lead from a single opening to 3 bins labeled ABC as shown. If a ball is dropped into the opening, it will follow the path and land in one of the bins. Okay, everything is fair. So left or right and over left or right. Okay, go all the way, and we've got 3 destinations. So the ball must end up in one of the 3 buckets, barrels, 3 positions. And it's a bin anyways, the word is provided here. What is the probability that the 2 balls land in different bins? Okay, let's just see. To find that final answer, we have to calculate the probability for this A and B and C. Okay, so I don't see any good method of doing this. Just to draw the map and calculate step by step. Okay, I'll copy the map, so this is what I'm doing here. You don't need to see the paper. I'm just drawing the whole thing. Okay. Not as good as the original, but I think that makes sense enough. This is B and this is wait a second. Okay, this is just a C. Okay, so from here to yes, that's it. So this is A. Okay, this is B and this is a C. Okay, that's it. Let's just compare. Okay, this is original. You have the original here. Okay, and here, this is what I have here. Basically the same thing. And let's calculate the probability just node by node. Here it is 1. It drops down from here, and then it is half and half, right? And here, this one comes from over here. And if the ball is already here, So it's a half chance that a ball moves on from through this, along this line. So it would be half of half, that is 1/4. This is, for the same reason, another 1/4. And this is actually, there are two ways to do this. It's either 1 minus 1/4 minus 1/4, or it's just a half of this plus half of this. I'm gonna choose the second way, okay? So it's 1/4 chance that the ball goes along this path, and 1/4 chance the ball goes along this path from here. And in total, it is 1/4 plus 1/4, that is 1/2 chance that the ball comes at this point. And then let's move on to this. What is this? This is half of 1/4 for the same reason. So this is just 1/8. And let's see this point. This is half of 1/4 and half of 1/2, right? Each one, so half chance the ball turns to the right, and half chance the ball turns to the left. So half of this plus half of this, that is 1/8 plus 1/4, that it would be 3/8. And how about this? This would be, again, this is half of 1/2, and is this half of 1/4? Think. This is actually not half of 1/4 because we don't have this branch here. Okay, this is chopped. We have nothing here. So whenever the ball is here, it has to go down to this node. It's 100% thin. So it's just 1/4. This is half of 1/2. That is called 1/4. This is a whole 1/4. It's 1/4 plus 1/4. That is to say that is 1/2. 1/2. And if you just add them up, it is 1/8 plus 3/8, that is 4/8, plus 1/2, that is 1. So it's kind of a double check, and you know that everything is so far, so everything is so good. And then what is the probability of A? This is just 1/8. We've already got it, right? So PA is, okay, it is 1/8. And how about PC? Okay, let's see. PC is not 1/2 because it's a half chance. And PC would be half of this. That is half of 1/2. So PC would be 1/4. And of course, let's see, this would be half. Is a half? It is not half. It's a whole because we don't have this branch. This is chopped. So once the ball is here, it has to go over here. This is 3/8. But this is half of 1/2. So that is 1/4. 3/8 plus 1/4, that would be 5/8. So here, it is 5/8. I would like to write that PB equals 5/8. It's a kind of a double check. Let's add them up. 1/8, 5/8, that is 6/8. 1/4, that is 2/8. 6 plus 2 is 8. So everything add up to 1, which looks good. Okay, now we've got a PA, PB, and PC respectively. But you see, we got two balls, right? We dropped two balls, and what is the probability of that two balls landing different bins? Okay, so that's something like that. We can do plus or we can do minus, but if you do plus, you have to consider the order thing. Okay, it could be, say for example, A, B. The first ball goes to A, the second ball goes to B, or maybe the first ball goes to B instead, but the second ball goes to A. That's a BA. So A, B, and BA are different, and you have to consider all 6 different combinations, which is not that good. So I decided to do minus. Okay, I'm gonna deduct those bad situations, those bad probabilities from the whole, which is 1. So it would be 1 minus PAA minus PBB and minus PCC. Okay, so AABBCC would be 3 bad cases. I just want to deduct them, and the rest would be all good. And this is 1 minus, what is AA? 1/8 times 1/8. Okay, shall we do it fast? Okay, so it's just 1/8 squared. And minus, what is BB? 5/8 squared. What is CC? 1/4 squared. Oh, let's just say 2/8 squared. Okay, because later we're gonna have a 64 on the denominator. So, and now it's just a matter of calculation. 1 minus 64. On top, it would be 1 and 25 and 4. Yes, everything looks so good. And let's just move on. 1 minus, on the top, it is a 30, right? Is that 30? Yes, it is 30/64. And then finally, it is 64 minus 30. That is 34/64. And of course, this one can be simplified to 70/32. And I think that would be the final answer. Let's see if we have this Option 70 over 32. Come on. Yes, we've got this one. A, 70 over 32. 17 over 32, which is reduced from 34 over 64. Okay. And here I used a minus trick. Okay, to minimize the calculation. Otherwise, as I said, I would have to consider 6 different combinations and add them up. And here it's better, clearer. We just minus all those bad cases. And here, this is important. When you calculate each node, you have to be very careful. For example, this is not 1 over 4. This is actually, this is not half from 1 over 4. It's a whole from 1 over 4. And this is a half from the 1 over 2. Okay, you just need to be very careful about these issues. And of course, at every level, you can double check to make sure that all probabilities add up to 1. And it starts with 1 and end up with 1. And that's it. And once you've got the 3, then you can move on to the next step. And you can do plus if you like, but I'm doing minus, as I said, to minimize calculation. And the answer is, again, 17. This is a secondary, but 17 over 32, which corresponds to the first option. Okay, so that is problem 24, and I will see you in the last video, which talks about problem 25. Okay, bye.